Okay, so I saw a lot of people write it out as y equals 2x plus 3. And you could do that when you copy it into your notes or like onto your homework assignment from the textbook. And then change it x equals 2y plus 3. Remember, don't bring the 2 over with the x. It's just x that you swap in. Okay, subtract 3 from both sides. That looks like a 2. So I'm just going to write a 2, so I'll change it. Subtract 3 from both sides. And then divide by 2. So I had a lot of people who wrote it like this. And I will accept that. That's fine. Okay, and I'm going to go ahead and stick a y inverse on it. Okay. You can also, if you want, like simplify this so it looks more like slope-intercept form. Just remember that the x gets divided by 2 and the 3 gets divided by 2. So you could have something like x over 2 minus 3 over 2. Or this is really like 1/2, isn't it? So we could say, so we can see the slope 1/2 x minus 3/2. Those are all the same answers. And I'm okay with all of them. Questions, concerns? Pretty easy, right? Okay. Tomorrow is going to be, I think, the solving part is not so bad. It's like when you see a cube tomorrow, then you'll cube root. So your answer is a cube root. The hardest part about tomorrow is we're going to have to think about domains. So that's always kind of like the tricky thing that we have to consider. Okay, so any of those are good answers. All right, the last thing that you need to know. How can you, given two functions, verify that the two functions are inverses? Okay, so this is verify inverses. I guess I would argue, or we could argue, there's probably lots of ways to show that things are inverses. If we just took one equation and we switched x and y and solved for y, and then it was the same as what the other equation was, couldn't we say they were inverses? Or what if we just graphed both of them, and then we saw that they were a reflection in the line y equals x? Wouldn't that show that they were inverses too? Okay. But there is this specific thing that you need to know, and you'll be quizzed and tested over this. And it will say in the directions, I think we changed it so that you know how I want you to verify the inverses. But it's verifying inverses by compositions. Because I said this earlier when I had that first slide and I said inverse functions undo each other. If you combine them through composition, all the numbers that are happening are going to cancel everything out and you're just going to be left with x. So if you do the composition f of g of x, it will equal x, and if you do g of f of x, it will equal x. And technically, to prove inverses through compositions, you would do both compositions. So we'll do one example, and I think you'll find out this really isn't so bad. It's kind of nice because then everything just cancels and you get to x. And usually, if I give you a problem to verify inverses, it's going to work out. It doesn't have to. Of course, you could answer no. But it usually, if I give that to you on a quiz or a test, it will work. Okay, so we're going to do f of x equals 2x plus 4, and g of x equals x minus 4 over 2. Okay, if I want to verify through compositions, I can start with either composition. I'm going to start with f of g of x. And remember, think about what a composition means. It's a substitution. I'm going to take g, x minus 4 all over 2, and I'm going to replace it in f of x where I see x. So it's going to look like 2 times x minus 4 over 2 plus 4. Now you just have to follow order of operations. Parentheses, there's really nothing I can do inside, x minus 4 over 2. Exponents, I don't have any. Multiplication or division, 2 times x minus 4 over 2, what happens? 2 over 2 is going to cancel. It's like 2 over 1 times something over 2, they cancel. So I have x minus 4 plus 4. undo the addition and subtraction. Minus 4 plus 4 is x. And then I should show that g of f of x is also x. So now I'm going to take the 2x plus 4, and I'm going to put that in for x and g. So that's going to go up in my numerator. So I'm going to say 2x plus 4, and then I'll have a minus 4 all over 2. Now notice I always put, when I like substitute in, I always protect that with parentheses. But like in this one, I don't really need parentheses because there's no exponent or there's nothing that getting multiplied in front. So now I can kind of just simplify, like ignore the parentheses and do like associative property. In the numerator, 2x plus 4 minus 4 is just 2x. Divide by 2, and x is my answer. Here's what I don't want to see on a quiz or a test, but I see it quite often, and I get it. I also am lazy. I have always copped to that, right? I get this a lot. So like you're doing f of g of x, and you set it up. And then I'll see this. I mean, yeah, it's true. All those things cancel. Okay? But I'm not really sure that you actually know that. Right? Like, I don't know if you did it in the right order. Like, I should see some steps to simplifying. Like, ideally, if they are inverse, they are all going to cancel, but you want to do, like, one thing at a time, cancel it, and then see how it goes, so you see the progression. I don't give full credit for that, because I'm like, I mean, I don't know, are you just canceling everything out and saying x is left over? What if it really isn't equal to x, right? So just kind of be aware of that. I get it. I like to be lazy, too, but on this one, you should show some steps. Okay, your homework assignment, just FYI, and we've got a nice little chunk of time here. Maybe like 7 minutes. Okay, about 5 minutes. Page 281. The 15, 17, and 19, it might ask you to graph both. If you want to graph just to like, you know, help you understand that whole like reflection in y equals x, that's fine with me. But I'll say you don't have to graph them if you don't want to. And then 22, 29, 47, 49, and 70. And tomorrow, we'll do nonlinear functions.